All right, so let's talk about another use of the integral. All right, and this one is the integral of a rate gives us the total change. Okay, let me give you an example. Integral of velocity is displacement, right? Velocity is the rate at which our position changes, and displacement is our change in position. Okay, so when we take an integral of a rate, we get the total change. All right, let me give you another example of how we might use this. Let's say we have a bucket of water. Yeah, that's a bucket of water, but it's got a leak in it, so it's starting to drip. It's true that a bucket of water will drip faster when the bucket's pretty full versus when the bucket's pretty empty. Then it'll drip pretty slow. All right, so the rate's changing. So if we want to know the total amount of water that is dripped out, we take the integral of the rate at which water drips out. Okay, or there's this example. A factory produces bicycles at a rate R of bicycles per week, where R of T equals this. How many bicycles are produced from the start of week 2 to the end of week 3? Okay, so they give us a rate. So if we want to know the total change in bikes produced, we take an integral of that rate. Okay, graphically what's going on is this. Here is a graph of the rate. Okay, so in bikes per week on the y-axis and weeks on the x-axis. Okay, so this is not a graph of how many bikes are actually produced. That's the rate at which they produce bikes. All right, so for some reason or another, they are getting better at producing bikes. Maybe they have more customer demand, so they're producing more. Maybe they're just getting better at it. Maybe their machines are more efficient. Whatever it is, they're producing more bikes per week as time goes on. And what they're asking us to do is say from week 2, the beginning of week 2, to the end of week 3. End of week 3 is the beginning of week 4, right? Figure out how many bikes they produced. So we can't just read these points. Instead, we find the area of this region, right? And let's do a units check. The y units are bikes per week, and the x units are weeks. So when we multiply those together, we'll just get bikes. All right, so the area of the shaded region is bikes. Okay, so graphically that's what we're doing. So now let's do it with calculus and symbol pushing. Okay, so we want to take the integral of the rate. And we want to evaluate it from 2 to 4, because remember the beginning of week 4 is the end of week 3. So let's take the antiderivative. 95t plus t cubed minus 1/2 t squared. And we want to evaluate it from 2 to 4. So 95 times 4 plus 4 to the 3rd minus 1/2 4 squared. Minus 95 times 2 plus 2 cubed minus 1/2 2 squared. All right, 95 times 4. It's almost 100 times 4, but we got to subtract 20 from that, so that's 380. 4 to the 3rd is 64. 4 squared is 16. Half of that is 8. Minus 95 times 2 is 190. Plus 2 cubed. 2 squared is 4. Half of that is 2. 380 and 64 is 444. 444 minus 8 is 436. 190 plus 8 is 198. Minus 2 is 196. All right, so that's like subtracting 200 and then adding 4. So let's subtract 200, 236. And then let's add 4, 240. All right, so according to our calculus, 240 bikes is how many bikes were produced during week 2 and week 3. Let's do a quick check with our graph just to see if that's a reasonable answer. All right, so the original rate at the beginning of the time period was about 100. Okay, so let's say it did 100 bikes per week over 2 weeks. That would be 200 bikes. All right, but this would be an underestimate, right? Because they eventually, over the 2 weeks, they got better at producing bikes. So we'd be missing out on this area here. And our answer is more than 200, so that's good. Let's look at their faster rate. Faster rate, if I were to estimate, I don't know, 140. So if they did that for the entire time, 140 times 2 over the 2 weeks, that would give us 280 bikes. But that'd be an overestimate, right? Because they weren't working at this faster rate the whole time. They were working at a slower rate for some of the time. Okay, so our answer actually happened to be smack dab in the middle. I don't think it's necessarily true that it is smack dab in the middle, but I think we took some liberties with our estimates. But the fact that it's in between 200 and 280 is excellent. Okay, if you have any questions, write them down. Let me know tomorrow.